compound microscope. A compound microscope is an optical device that makes use of two lenses, one objective of smaller focal length and other eyepiece of larger focal length. Here, this is objective, this is eyepiece. Object is placed here, AB is object. So one ray goes like this and it passes through FO, and another ray goes through optical center and it meets at this point. So image is formed here. And this image, this point is FE. So this lens will act as magnifying glass and its final image is formed at D, least distance of distinct vision. Now, let's write the formula for magnification. So M is given by beta upon alpha, which is tan beta upon tan alpha, and tan beta will be equal to h dash divided by this perpendicular divided by base UE, and tan alpha can be found from here. So tan alpha is, this is object, this height is h, and this angle is alpha, and image is found at D. So it will be equal to h upon D. Here alpha is not shown. Instead, this figure shows alpha. So it will become h dash upon h multiplied by D upon U. So we can write it as M equal to magnification due to objective lens times magnification due to eyepiece, ME. Now we know that MO is, here we have got as h dash upon h, which is also equal to, here if we consider these two similar triangles, triangle ABO and triangle OB dash A dash, then h dash upon h perpendicular here, this is perpendicular, then base, so this base will be UO and this base will be VO. So we can write it as VO divided by UO. And the magnification of magnifying glass or simple microscope we have already done, which is given by 1 plus D upon FE. Now, if we combine the two, so we get M equal to MO times ME, and MO is VO divided by UO times ME is 1 plus D upon FE. Now, let's do some approximations. So here, approximation is we take U is roughly equal to minus FO. We assume that object is placed very close to focus. Focus is here, object is here. So this is one assumption. And second assumption is VO, this length is assumed to be length of the tube in which these two lenses are fitted. So if we put these two values, so we get magnification M equal to, in place of VO, we put L divided by, in place of UO, we put minus FO times 1 plus D upon FE, which is final expression for magnification when image is formed at least distance of distinct vision. Now, consider the second case when image is formed at infinity. Here, this is object. These are the two rays. and they meet at this point, and here this point is equal to focal length of eyepiece. That is why its final image is formed at infinity. So we have studied in case of simple microscope when final image is formed at infinity. In that case, its magnification is given by d upon fe. So total magnification will be MO into ME, and MO is, as we have obtained earlier, that is L upon FO times ME is D upon FE. Now, tube length, when image is formed at infinity, in that case, we take tube length L equal to VO plus UE, VO plus UE. It is clear from here. This from here to here, the distance between two lenses. So this distance is VO and this is UE. So generally, VO is to the right of this lens, so it will be positive, but UE is to the left of this lens. So for this lens, it will be negative. So we write it UE with modulus. And when final image is formed at infinity. So in the, sorry, here, this is not that case. This is the case of this one. So here this distance is VO and this distance is UE. So length of the tube will be VO plus UE. And in this case, in particular, when UE becomes FE, then image is formed at infinity. So expression remains same, but in this case, we write VO, but UE is equal to FE. So we can put the same thing. We can say that L equal to VO plus UE. It will hold in both the cases, but in the second case, when image is formed at infinity, UE becomes FE. Thank you for watching.